Good afternoon. My name is Steve Berger, and I farm in southeast Iowa with my dad, who happens to be back here this afternoon. And we're going to talk a little bit about cover crops. And if I had one slide to show you, and that's all I got, just to talk about cover crops and why we do it, it would be to control soil erosion. And I pulled off a third-party slide or from Bing Maps, which everyone go on the computer and like the bird's eye view. And we're looking at a picture of a rye cover crop taken in the spring of the year. And you can see up here in the top, there's just no soil erosion where the rye is planted in that field. Of course, you've got terraces and so forth. You look at the two fields to the south, or no-till fields, you get the typical gullies. And then if you go over to an aggressively tilled field, the gullies get even deeper to where you can't even pass. So, I mean, that's why we use cover crops. There's a lot of reasons to use cover crops. There's a lot of different kinds of cover crops. But we use cereal rye primarily on our farm and to stop erosion. And I think there's some other advantages too to using cover crops. What we do, just real quickly to get that accomplished, like in the spring of the year here in a month or so, we'll go out and start spraying. It's not always in March. It's more typically April because a lot of times we have snow cover in March. And then we're going to plant in April with a planter there you see. Then we're going to come back and plant our beans next. It's usually about that first week in May, sometimes earlier, but mostly May. And we do a little bit of side dressing, 28, 30, 32% side dress. Then we let our crops grow. And then in the fall we come back, and then we're right at harvest. We're harvesting corn, but in that same day we're out there in the field drilling. You probably can't see it, but there's a drill in the field the same day as the combine. And that's not for the camera, but that's what we do. We get the grain cart hooked up, the dryer's running, and the drill's going because we want to take advantage of the growing period for that rye. That's just as important to get the rye growing and established in the fall as what it is to get the corn growing, in the spring of the year. So we're drilling right away in September. Usually our harvest starts about that time. Then we're doing some dry spread ammonium sulfate to start breaking the carbon down. So we're doing some AMS in the fall and some potash too. And that rye starts to grow. It's going to grow just based on the growing degree units. If you have a cold, wet fall, you're not going to get much growth in the fall, but if it's warm and you can get a lot of growth, it's just like growing degrees. So we get the growth on the rye, and then we have a lot of manure to spread. So we're also spreading manure in the fall too. And so that's kind of in a nutshell what we do in the cereal rye. Oops. We started no-tilling back in the 1970s. We had a really active county, really active soil conservation board, a really aggressive extension director, Jim Freer. The retailers really got involved, and we had some interest, and quite a few farmers started no-tilling in Washington County back in the 1970s, and this was our first field. And it was cereal rye, and that was way before Roundup. And we didn't know how to kill it, but that was, of course, using paraquat or gramoxone today. So that was our first field. That was a brand new Kinsey planter, John Deere units on a Kinsey bar. Bought that from John Kinzenbaugh himself. We put together in the truck, hauled it home, and put it together in the shop, and that was our first no-till experience. And 35, 36 years later, we're still no-tilling. Here we're in a field of Pioneer seed beans, just drilling soybeans into cereal rye that had been killed. We let that rye grow a little bit taller. And so the key thing is to remember that it's not something you're going to jump into next year and then jump back and forth, go from tillage, no-till, tillage, no-till. It's a lifelong decision that you really got to kind of make and think about. And I think that's the key. That's one of the key things there. So one, we're doing rye to stop the erosion. Two, you got to realize this is kind of a long-term decision. I look at, if I had to write a book about our farm, I would say that adding on-farm grain storage, bringing a swine operation into the farm, and then no-tilling would be one of the three biggest things that affected our farm, and I think that the no-till is a big part of it. So. This is a view from 5,000 feet. You can kind of see the cover crop in various stages of growth and being killed, I guess, in the spring of the year. We're thinking in terms of watershed. We farm about 2,200 acres, and we aim to make sure that everything's covered with cereal rye every year. So we had our local soil scientist, Jason Steele, down in Jefferson County, and Kathleen Wyota, who's the state geologist, do some slides of our soil profile. The one on the left is a long-term cover crop, no-till, demonstrating the pore space. We want like about a 50% air, water, 25% air, 25% water in the pore space. And if you look on the right, you can see an aggressively tilled field in the same county, Washington County, where there's no pore space, you know. So the size of the pore space between the soil plays a key role in the plant growth. Infiltration rates will be a lot better. You'll take rain, you can take a big rain and you can just see how that can soak in. Your organic matter starts to creep up. And so that is an example of good soil structure. There you can see it in a picture. The one on the left of the right cover crop is crumbly. The one to the right, you can make mud balls out of it. Same soil type, just jumping across the field on an aggressively tilled field. The one on the left should be able to hold combines, manure spreaders. You should be able to take a heavy rain, soak in. You've got more microbial life going on. The root system's adding organic matter. And so we think that on the left is a healthy soil, just a better structure. That's the key thing. I'm going to go through a series of slides and kind of demonstrate what that's like. And when we have rye on the surface, it's not just grass on the surface, but we've really developed that soil profile over time. Like I say, you just can't jump in and out of it. And after we've done this for a few years, you know, you can just start to see the results. This is after a 3-inch rain here a couple years ago in April. I took that on a Sunday. We had about a 3-inch rain about 5 hours ahead of that. You got clear water. That's in a rye field that will get planted to corn in about a week. This was in '83 when a crop scout. This was an early rye field. The one on the top you can see is an aggressively tilled field with the soil eroding. Those are both non-HEL farms, A horizons on the prairie. That lower one just sold for about $11,000 here a while back, you know. But you can see the erosion, and you can start to see the organic matter coming off of some of those prime prairie soils. That's Mahaska soil there in that top, getting away. There's another one here taken a few years ago after the same 3-inch rain. It costs money to plant rye, but you know, you're not going to straighten that waterway up for nothing either, you know, so you're going to have repair costs going back in there. Here's a good shot of one on C&D slopes on some of our rye fields. That's like a 3-inch rain. Organic farm, they're just north of Kelowna, heavily tilled. That was back in 2007. This is a 6-inch rain. This is in April last year after a 6-inch rain. Of course, the terraces are really helping us out. Long-term no-till on the rye is helping to hold that soil in place. That soil is more resilient. It can take a greater amount of rainfall, and it just doesn't move after rain. That's the whole point of it. And it takes a little time to make that happen. Then we grow corn. We can get good corn stands established in that. Here's another one. This would be a Farm Progress Show site in Washington County on A slope soil eroding off. You know, flat farms erode too. Back on a C&D slope farm after a 6-inch rain, staying put. There are just not any rills out there. This is in Iowa County about 4 or 5 years ago. That field's been planted to corn. You can count the kernels. You can see the plow layers on that, you know. And so we're thinking about, when we're talking nutrient management, you know, we're losing our chemicals, we're losing our swine manure. You know, all the work that goes into picking our seed and selection doesn't really matter, you know, if you're going to lose it like that. So rye cover crop field again. You see 3 different, you've got a tilled field right there with gullies, and you've got a rye field that hasn't been sprayed, and then you got when the upper right-hand corner has been sprayed going to corn, you know. Stop. This was a rain in February last year, 2013. You can get some pretty erosive rains when the soil's froze like that. We're holding it together pretty good. Another one, that's an A slope field. Water runs off of that too. Takes the energy right out. I mean, so you can kind of get the idea. So we kind of go back and forth. You can see the difference between the tilled fields, cover crop, and the ones that aren't. And then you can raise pretty good corn crop on those fields too. We've learned that, and there's some strategies for doing that, and we'll cover that. What the cover crops do is that raindrop has a lot of kinetic energy. And so what those cover crops and residue do, whether it's corn stalks on the soil or the residue breaks that raindrop up, shatters it, takes the energy out of it. So when it hits the soil, it's not doing as much damage. Then the biggest probably advantage is the root system. That's where we get our organic matter. That's where we got our organic matter from the prairie soils. That's why Iowa has its rich soil from the prairie grasses. So the root growth, the microbial life in that soil comes from that, and that's probably more important than the top growth. Whatever we have on top, most of that residue oxidizes off and doesn't go to organic matter. So we're getting organic matter growth from the roots. And this just demonstrates photosynthesis, that 8th grade formula. The field on the right, it's there's not taking much in, but on the one on the right, taking some carbon dioxide and some water in with that light energy, then we get that simple sugar. And that's where we get that carbon, and that's the carbon sink, and that's where we're starting to put some organic matter in the soil. Doing some root digs here, Dan Towery out from Indiana. Seeing roots go down up to 40 inches on years where we get good rye growth, and that just strictly depends on how tall your rye gets, But this year, where we had a lot of growth that winter, we had some roots down up to 40 inches on the rye. And demonstrated, this shows a fence row. The fence row is a real potential, shows the potential of the soil, the way it was when Iowa was founded back in the 1840s. And so we just decided we'd go and soil sample that. And so here's a soil sample, grid soil sample, and then we're showing the organic matter here. And there, along this fence row here, you can see where we're running organic matters from 6.6, 5.8, 4.4, 5.1. Then you can get out into the field and kind of see those organic matters just roughly half. So you can see since we started farming in Iowa, the last 170 years, 150 to 170 years, we've lost roughly half our potential and just oxidizing off the organic matter by tillage. Anytime you run steel through soil, you introduce oxygen, pulls the carbon out, goes off of CO2, you oxidize that soil off, and through soil erosion. And so that's what you do. That 4.7 is a barnyard, and that hadn't been there for 50 years. And so you can see that's why that shows up. These are some sand spots, sandy. We got a lot of underlaying sand in our area. But so I guess we're trying through cover crops is to make more of our fields like fence rows. We're trying to keep cover growing throughout the entire year of the corn and soybean crop, 5 months out of the year, and then the rest of the time period we want to have something green growing. We never want to see any soil showing at all if we can help it. And like I say, we start as early as we can in September when our first corn comes off. We drill about 90% of a rye. We just use a crust buster drill, drilling about 56 pounds of cereal rye. Grows like that, 10-inch rows. And we do some flying once in a while. We'll fly on some cereal rye. Can't see it too much here for this picture, but there's aerial seeded rye emerging in the soybeans. Cereal rye coming up in corn. And then we do some manure. Most of our manure is custom applied with different applicators. This happens to be a drag hose. Actually, we're applying on rye. I had them surface apply this just to see what we could, whether the rye would survive that. So, in the spring of the year, March is go time for rye. Rye is growing really lush and green. And then we're going to come back and spray that. A cereal rye kills real easily. We're going to kill it, and then we're going to come back and plant it. And so now we're planting into that rye residue. We're putting on about 60 pounds of 32% off to the side, about 3 inches, and we're doing about 3 gallons of a pop-up, 624-6. And in that pop-up, I'm also putting on some insecticide, like a bifen or a second-generation pyrethroid to get the insects, and that's really important. You got cutworm moths coming in laying eggs, you got cutworms, you got secondary insects from the manure, and then later on, we'll have army worms, but we'll take care of that with a post-applied treatment of insecticide. But anyway, back here, we're planting corn again, getting 2 forms of nitrogen on. And I think that's pretty important, in the cover crop system. That's what it looks like after we're planted. Pretty good seed bed. Corn comes up. Try to get good stands, which is, we absolutely have to do that if we want to keep up with yields. You just have to have ear count, good even emergence, and that can be a real challenge in rye too, and that's what we spend most of our time on, trying to work on establishing good stands. Here's another rye cover crop field that's been killed. You really can't see the rye, but the rye residue's there, and just demonstrating, as we stand right here, I think that corn can compete with any corn, in the county, as far as, yield potential. At this point, I don't think the rye has hurt us anything from this point on, Now, You might feel differently. I don't know. We'll just have to see. This here is a picture of 3-year continuous corn. And then we also side dress too. We side dress about 50 pounds of nitrogen about this stage here, and we also threw a sprayer on so I can get my post spraying done while I do get my nitrogen on. And then we're, like I say again, we're drilling beans. All our beans are raised for seed beans for Pioneer, so this is a Pioneer seed field going in. Beans come up real good. This is the various stages of cereal rye. Some people ask me, when do you spray your rye, or what's the cereal rye look at different stages? Rye just has a different look just depending on the year and how tall you let it grow, how the season went, how warm, how cold, how much rain you got. We just never know what Mother Nature's going to throw us, And this rye comes up, it's got kind of a reddish color as a real young plant. This is like in the fall of the year. Come back in the spring of the year, it's really starting to grow. March is go time for rye growing just like June and July is for corn. Come back. Sometimes we'll let rye grow a little taller and plant some soybeans into taller rye. We don't generally do that too often. We definitely probably don't do that in corn until we learn more about how we can manage the nitrogen with that. But that's not typical. This here is typical. Where we'll let that rye get, 2 to 4 inches tall, and then we kill it off, And I guess my thinking is if we took a 2-inch rain tonight, I think I could hold that field together. So I've accomplished my erosion goal, and then I think we can get a pretty good corn crop established in that. I don't think that's too hard. I think a carbon-nitrogen ratios, and at this stage here, that rye crop, the C to N ratio is going to be pretty low because it's mostly lush, it's mostly water, there's not a lot of carbon, it's not very stemmy at that point. So we're not going to have a lot of competition from the microbes stealing nitrogen from the corn. So the C to N ratio is pretty low here. Whereas as this gets taller and taller, your carbon-nitrogen ratios are going to go up. And as microbes they love to digest that carbon, and they're going to take a nitrogen with them when they digest that carbon, and they're going to steal that nitrogen from the corn. That's why we get yellow corn. And that's why farmers don't like cover crops and don't like the grow 'em, because it's a nitrogen issue, But I guess the take-home point here is, if we can grow rye in about this height and plant corn into it, that's a pretty good goal to have. We've got annual ryegrass on the left, which is a whole different species than the cereal rye on the right. We do a little bit of annual ryegrass, but not very much. There's just another picture of the annual rye on the left. It's a shorter statured plant. Really good root system. This is cereal rye here, really good top growth. The root systems are about equal. I think the book would tell you the root systems will go deeper on annual ryegrass. When we had the soil tilth lab come in and do root digs or probe down, actually the cereal rye and annual rye were about equal here, down to 42 inches. So we were getting about a 42-inch depth on that. Now this was an open winter where that rye grew really good, and that I would say not maybe be a typical year, and we do a little bit of oats. Oats is another crop that I think can work in certain places in Iowa to the south more if we get it planted early. It's great on taking up nitrogen, and it'll winter kill, and then you can come back in the spring and you won't have to spray it, and you can plant into it. It's going to release that nitrogen, and that nitrogen will be available for the corn. So I think it's important to have a mixture of species, not just one species. And we're pretty tied to cereal rye, and so I would like to try to maybe add a few more cover crops. And I think oats is one that I'd really like to do it, but we've got to get it in early. Get it in early in the fall. The big elephant in the room is, is the yield deficit with corn following corn following rye. People say, well, don't you take a yield hit, And you sure can. There's sure the option of that happening. Here was a study done by the Soil Tilth Lab at Ames. All this was done back in '95 through 2001, a 6-year study. It's just showing about a 20 bushel deficit with rye following corn. I mean, that's a good replicated trial. I mean, that's a good study, and that really happened. But I guess what we try to do on our farm, we're looking at ways to chip away at that yield deficit. And like I say, that can sure happen from a lot of different reasons. And that's why we have to manage it and we have to learn from it so we don't have that, because there's nobody going to do this. And there's probably nobody going to do it if you even take a 5 bushel hit, And so there's ways that we can learn to manage around that. And what I found, if we can get our planter set right, manage our nitrogen, carbon-nitrogen ratios, understand where that nitrogen's going so your corn's never nitrogen deficient, take care of those insects. That's a simple one. Armyworms, you can just add a little bifan. And then there's also a time factor involved in, if you just jump in the no-till and cover crops next year, it ain't going to be all just wonderful. It's going to take a little bit of time to do that. And I don't know what that time is, whether it's a couple years, 3 or 4 years, or what. But there is definitely a time factor in that. And I think I'd be lying if there wasn't. But I guess to get rid of that 21 bushel deficit that I showed in that last slide, just some planter adjustments, nitrogen, insects, and time. And I'll just go through them real quick. We did a plot this last year where we planted corn. We had a university come in and do a seed treatment plot, about 1 acre. Planted the same day. Here's the Almaco planter set up for no-till, so to speak. And here's our planter here. And then that's what the plot looked like. It might be a little hard to see from where you're sitting, but that's a plot put in by the plot planter. It's supposed to be a no-till planter, And if you look at that, you would say, yep, that's exactly what I think a cover crop is. That's the way my neighbor's cover crop looked 10 years ago, and that's why I would never do it. You're seeing about 2/3 of a stand there, You can kind of see the dividing line here. Here's the plot that was put in, and then here's what we planted with our planter, probably just a couple hours apart. There's a pretty big difference there. This corn averaged 230 dry when we picked it. The plot was in that 195 to 200 bushel. Now the plot work was excellent plot work. They were studying seed treatments, and they can factor all that out, so that the yield deficit didn't hurt them for their seed treatment trials or anything. But if you were just going to just show that plot, yeah, they were behind several bushels, and that just comes from a simple planter setting. Kind of see the difference here. This is our planter. There's only like 3 kernels out of place there, which would be your 5%. The end rows look pretty strong. Here's the plot. So the take-home message there is get your planter set right when you're in no-till cover crops. Nitrogen. We use ammonium sulfate in the fall to get the carbon-nitrogen ratios in line. We use a little bit of anhydrous where we're not using manure. Have a little bit of turkey manure we get from a neighboring farm, and then when we're planting, we're still getting about 60 pounds on with a planter and a 3x2, and then some pop-up, and then of course we're coming back and side dressing. Learning how to manage that nitrogen so that corn plant's never short. And that's a pretty hard thing to do because we're never quite sure where that nitrogen's going to be based on the year when it mineralizes and available for that corn plant. So we're learning all the time here. This just shows some nitrogen uptake on the right with some anhydrous, so you can definitely see the rice taking it up. This here shows down in the floodplain where it flooded. You had about 6 inches of corn stalks. The microbes are going to go crazy, try to digest that carbon, steal the nitrogen from the corn, and the corn goes yellow. This was just simulated from a flood. You see what happens when things are normal. You add those corn stalks, that corn goes yellow. Well, the same thing happens when you use cover crops. This just shows that we need to keep insecticide in the rotation when you're doing rye cover crops. Your varmints they're attracted to the rye, armyworms, cutworm moths. Ohio State says it takes 7 to 9 years on continuous no-till before the soil recovers. I'm not sure if I agree it takes that long, but there's a time factor involved there for that soil to get that profile changed over to where your pore spaces and your structure changes. And maybe it will speed up, if you add a cover crop. That change will happen a lot quicker. This just shows soil structure back in the 1970s versus what it is today, how it's changed. People are concerned about corn stalks and digestion. This here's 270 bushel corn on a plot situation where we just drilled in right behind it. Once you're in long-term no-till, you're not going to have any problems letting those stalks digest. The microbes are going to take care of that. You don't need any choppers or anything to do anything with those stalks. That's not a problem. You're not going to have any problem. Last 4 slides here are just going to show what our organic matters have done through soil tests, 2004, 8, and 12. In 2004, this farm here had about a 3.3 was the same in 2008, then 2012 it jumped to a 4. It probably wasn't a 3.3 in 2008, and it probably wasn't a 4 in 2012. But I think the point is it's starting to creep upward about 0.1% a year. Here's another one. 2004, we were 2.6, 2.8, 3.2. So our organic matters are going up. That's good because your cation exchange capacities will go up. Your water holding capacities will go up. You'll also get some nutrients. And those are dollars not back in your pocket, but those are dollars realized that you can kind of help pay back the cost of the rye. Here's another one. 3.2, 3.6, 3.9, 3, 3.3, 3.4. Here's a rented farm that didn't act like it's supposed to, but we're in Realville. That's the way it really happens. 3.1, 3.5, 3.3. But if you go from 2005 to 2011, we're going from like a 3.1 to a 3.3. So this is a new farm that's been aggressively tilled, and then we're just trying to get it back in shape. So it's kind of bouncing around there. My last slide, and I'll finish up. I guess my key point is we're doing rye cover crops. 1, to stop soil erosion. 2, it's a long-term deal. It's not something you can jump in and out of because the soil just isn't that way. You know, we're working with soil that's 5,000 years old to 400,000 years old. You know, soil don't change, you know, and just 1 year isn't going to do it on the farm. You got to be in it a while. And then I think my third point is I think there are some returns to be realized, maybe intermediate to long-term definitely, you know, from increasing organic matters and just keeping that soil where it's supposed to be. And don't leave the farm as an advantage to everybody, not just to you, but your neighbors also. So I guess those are my 3 key points. Thank you for your attention.